Hello, I am Ranju S from Cochin. I am working as an assistant professor in Sree Narayana Gurukulam College of Engineering, Kadayur. I am doing a machine learning project using Python under Skyfi Labs. This is a project assignment regarding the Boston house price prediction. Here, the problem statement is we have to train the data to predict the price of a house. Here we have a Boston house price data set. It consists of 506 data points. Each data point has 13 features and our target is price of the house. Now we can start our project. First we can open a Jupyter notebook and save it as linear regression. Boston house price dataset is already available in sklearn library. So we need to import it. Before that we are going to import some library which we are using in machine learning. So we can use functions whenever we need it. So we can begin with the NumPy. We can import NumPy as NP. So we can use NP to assess the functions of NumPy. Next we can import Pandas as PD. It provides data structures and data analysis tools. Next we are importing matplotlib as MPL to draw graphs. Import matplotlib.pyplot as PLT, where PLT is the object used to draw graphs. Next we are importing funcAnimation from matplotlib.animation. This module helps to generate animations that helps to visualize the learning process. Now we can import our data set Boston house price from the sklearn library using load_Boston function. This is the data we are using to train and test the model in our project. Next we are using mean squared error function to find the error between the predicted values and the true values. Next we have to split the data set into two, testing set and training set. We are using train_test_split function from the sklearn.model_selection. Now we have to import min-max scalar function from sklearn.preprocessing. Finally, we have to import HTML from ipython.display. This is a library which is used to display the resources on the screen. Let us begin with our first step, that is data processing. First we have to load the data set using the function load_Boston, and we are storing in a variable Boston. Now we are using a print function to obtain the description of the data set. This description provided by the sklearn library. So this is the description about the data set. Here we can see these are the attributes. Next we can store the features from the data set into the Pandas Dataframe. For that we have to pass the data to be stored, that is boston.data. And data comes from boston.data and name of the column boston.feature_names. Now we can print the features data frame. So here we can see each attributes. Now we can see the list of columns data contained in features. Next we can store the column target into a data frame called target. The target column in the dataset is also stored as the property of the object with the name target. So we are using the function pd.dataframe. And here we are printing the target. So this is the price for each data points. Here we have 506 rows and one column, that is the target. Now we can concatenate features and target data frame into a single data frame using the pd.concat function, where access is equal to 1 to make the concatenation column wise. Then here we are printing the type df and execute. So now we have seen how we can import dataset into our program. Here the target is also concatenated to the remaining attributes. So next we are using the describe function to see the complete description of the data frame. So this description includes count, mean, standard deviation, minimum and maximum values. Here we can see the count for all the attributes is 506 and the mean for each attributes and standard deviation for each attributes, like that. To perform the linear regression, we have to do correlation function. And correlation is a statistical technique that can show whether and how strongly pairs of variables in two columns are related. Let us consider two columns, x and y. High correlation means the change in the value of the x causes change in the value of y. Positive correlation means whenever x changes, y also increases. That means whenever x increases, y also increases. Whenever x decreases, y also decreases. Negative correlation means whenever x increases, y decreases, and vice versa. Now we can compute the correlation between attributes and target values. Here the Pearson is the standard correlation function. Here our object is to find the attribute which having highest correlation with the target value. So we have select each column by using its name. From list features and compute the absolute value of the correlation between each attributes. So now we can see the list features. We are selecting each values and compute the absolute value of the correlation. Next we have to make the list of pairs that consist of correlation value with the label for the respective attributes. This can be done using the zip function in Python. So now we have to sort the correlation values in descending order using the function sort function. And we are using a lambda function to extracting the key for sorting. And we want the correlation value in reverse order, so we are setting reverse is equal to true. And this will unpack the list into separate elements. So we get the correlation value in descending order with the matching labels. Now we can plot the correlation with respect to target values in a bar graph. So here index is the length of the number of attributes. So here we have to set the size of the figure just wider than the default, and plt.bar function is used to generate the bar graph that provides the label for x-axis and y-axis. Here we can see that x label is attributes and y label is correlation with the target variable. And plt.show function will plot the graph. So this is the generated graph, bar graph. Here we can see L stat has highest correlation with the target value. So actually L stat is the percentage of lowest population in the neighborhood. And the next is RM. It is the number of rooms in a house. As the number of rooms in the house increases, target value is also increases. So we got which attributes have high correlation with the target. So next we have to perform the normalization. In data set, two columns may be in a different scale. So this makes difficulty in interpreting the data. So the normalization process begins all the value into a common scale. So after normalization, it is easy to interpret the values. So here we are using min-max scalar function to scale the LSTAT values, and fit_transform function compute the minimum and maximum, transform the values into the normalized values. Fit_transform function output will be column wise, so we have to reshape the values. Similarly, we have to reshape the target values also. And here we are printing, after reshaping, we are printing the 5 values of y. Here we can see all the values are in between -1 and 1. During learning phase, our objective is to minimize the error. So actually we have to find the error, that is the difference between the true value and the predicted value. True value are the values from the data set, and the predicted value we compute from the given weights, that is M and C. So first find the difference between actual value and the predicted value. So here we are defining the error function. So inside the error function, we are first finding the difference between the actual value and predicted value, and find the sum of the square of the difference. Then divide the quantity by the number of samples in the data set to obtain the mean squared error. So here we are using mean squared error equation. So we have defined what the error function is. Next, we have to split the data set into training and testing data. It is difficult to test the model using the entire set of data. So a 20% of data is randomly choosing as testing data. Here we can see that we are using a train_test_split function to splitting the data, and we are choosing only 0.2, that is 20% of data for testing. Okay, then so this function, that is train_test_split, that is from the sklearn library, and this will provide a fraction of data set for testing the model. And the data set given in 2 parts, the features and target. This will return X train, X test, Y train and Y test. So next step for linear regression is to apply optimization technique. Gradient descent algorithm is an optimization algorithm to minimize a function. So now we can see the steps of computing the gradient descent. So we have to start with the initial assumptions for space positions M and C. Then we have to calculate the cost function. After calculating the cost function, we have to calculate the gradient at current position. Then we have to determine the direction to move. Then update M and C based on the learning rate. And repeat these steps until we get a cost function to an acceptable level. First, we can see how we can use update function to calculate M and C. Now we can define update function. So inside this function, let us compute the gradient underscore M. It is a predefined equation. Next, compute gradient underscore C. It's also a predefined equation. Then we can update M and C. And here we can see we are using a control variable learning underscore rate. Actually, this gradient underscore rate is used to control how much change in each integration, and it will return the updated value of M and C. Now we can define gradient descent function. So the gradient descent function, we have to pass init underscore M, that is initial estimation of M, and initial estimation of C. then ex ante, then learning rate, then iteration means number of times the iteration, then error underscore threshold. If the error falls below the threshold, the gradient descent process is stopped and the weights are returned. So we have to specify an error threshold. If init underscore m and init underscore c is closer to the target value, then number of iteration will be less. So these values gives a starting point to the gradient descent algorithm. First initialize m and c with the initial values. Now declare an empty list to storing the intermediate values of error values during our testing process. Then we declare another empty list to store intermediate values of m and c. Next we define a loop I in range iterations. So inside the loop we are using error function to calculate the error, and the error is stored in the variable e. Then we have to check whether the e is less than the threshold, error underscore threshold. If it is less than the error underscore threshold, we are printing error is less than threshold value and stopping gradient descent. So it will break the loop. Now store the error values in the list error values, and now we have to update m and c values and add update value to the list m and c values. After loop complete, it will return m, c along with the error values and mc underscore values. So here we can see how we can run a gradient descent. So we are initializing the value m is equal to 0. Init underscore m is equal to 0.9, init underscore c is equal to 0, and learning rate we are setting 0.001, and we are choosing iteration 250 iterations, and setting error underscore threshold equal to 0.001. And here we are using the gradient descent function, and we are passing all the arguments. Then here we can see double percentage time. So this double percentage time is a magic function. It is built in IPython. So here it will shows the execution time. Next we can see the visualization of model training. So here we are generating the animation to show the regression line changes over the course of learning. So in order to reduce the processing time of animation, we are choosing small values of m and c. Here the first two values denotes the start and end, and the third value indicates the interval. So next we are calling plt.subplot function, which return two objects. One is figure and the other is axis of the object. Then we will get the line object using the function plt.plot. Here ex ante coordinates, they are empty list, and set animation is equal to true. So this indicates that line drawn is to be animated. Generating animation requires two functions. One is to initialize the state of the graph, and another function is to update each frame with the new data. So the update function is called before drawing each frame inside the update function, and we have to set new endpoints for the line. So first we can define the init function. We are defining the init function. In this function we will plot the scatter plot of the training data. Next we will use the axis object to set the limit of the axis. That is, here we can see x dot set underscore x limit and x dot set underscore y limit. I mean, we will set the limit 0 to 1. Then we can define the update function, and which passes an integer denotes the frame number. This will update the coordinates for the line in each frame. So here we have to find the endpoints of the line, that is x1 y1 and x2 y2 respectively. So here the x value is this is minus x1 is minus 0.5, and y value we have to calculate using the line equation mx plus c. And in the case of x2 and y2 also same, we have to calculate the y2 using mx plus c, and using ln dot set underscore data function we are calculating the endpoints. We will set 2 endpoints to the line. Then it will return the line object. Once we have init and update function, we can use func animation function. So in this function we have to pass figure object and update underscore frame function, then list of frames, then init underscore function, and we have a keyword blit is equal to true to improve the performance. Now we have animation object. Next we will use the video function to provide the provided by the func animation object, and we have to pass it to the HTML function. So this will display the HTML video. Here we can see that the linear regression line is shifting the starting function in initial position to the final position. So it is starting from the initial position to the final position. Next we can plot the regression line upon the training data set x train as x coordinate and y train as y coordinate, and let the scatter plot to plot this, and we are setting the color B, that is blue. Next we plot the regression line. We already, that means we have x values we already have, and we have to find the y value, that is using the line equation mx plus c, and we are setting the color of the line is red, and here we can see the plot. Here we can see that the training data does not lie on a straight line. It has a slight curve. It has a slight curve in it. So the line that the model has predicted is a good approximation of the target value. So this means that the line gives a good prediction for the price of the house. Now we have to plot the error values. To plot error value, we are using plt.plot function, and we are setting the y coordinate as error values and x coordinate as are the list of values from 1 to n, where n is the length of the error values. Here we can label it, that is y label is error and x label is iterations, and here we can see the plot, and that shows that the value of the error is decreasing for each iteration, and after some iteration the graph is parallel. So now we have the final values of m and c. So using these values we obtain the prediction for the values in the testing data. So first we have to generate the list of predicted values using the line equation, that is mx plus c. Let us call this variable as predicted. We are using the vectorized operation described in NumPy. So next we are using a mean square error function from the sklearn library to compute the mean square error. Here we can see the value. Then let us put the x text and y text and predicted values side by side, and we can observe that the predicted value and list of target values. Now plot the predicted values against the target values. So here we can say that we are calling the data frame function, and then zip function, and we are passing x text, y text and predicted. So here we can see that x, target underscore y and predicted underscore y values. So we need to prediction in terms of prices. So here we are plotting, we will plot this using the plt.scatter function to plot the testing data with the function and color it as blue. Then we plot the predicted value with the function plt.plot, and the color is set to red, and we can see the line is decreasing in the same direction as in the testing data. Then next we have to we need a prediction in terms of prices. So to do this we are using a inverse transform function to scale the value back to the original representation. So first we must reshape the data to change the shape that is required by the scaler. Then we are using the inverse transform function. Here we can see that we are using inverse transform function to get the original scale data. Actually it is stored in the variable x test underscore scale and y test underscore scale and predicted underscore scale. Once we scale, we can remove the extra dimensions. Again we are using a zip function to display the actual price and predicted price side by side. Now we have completed the predictions. Here we can see that x values, target underscore y and predictor underscore y. So thank you.